We take our atmosphere for granted. It's the invisible, wispy-thin layer of gas that keeps us warm, gives us weather, and basically makes all life on Earth possible. It feels permanent, but what if I told you that our precious, life-giving atmosphere is actually leaking, right now, into outer space? Don't panic yet. Luckily for us, it's a remarkably slow leak. To understand why it's leaking, we have to talk about Earth's gravity. Gravity is like a giant invisible tether holding everything down. For any object to break that tether and permanently escape Earth, whether it's a rocket ship, a molecule of gas, or an ordinary house cat, it has to travel incredibly fast. Specifically, it has to reach escape velocity, which is about 34 times the speed of sound. Reaching that speed requires a massive amount of kinetic energy. To launch an average human at escape velocity, you'd need the explosive energy of an entire metric ton of TNT. Lighter objects require proportionally less energy. Launching a cat, for example, would only take about 1/10 of that energy. But individual molecules of gas are incredibly light, meaning it takes very little energy for them to reach escape velocity. Thankfully, heavy gases like the nitrogen and oxygen we breathe are mostly too sluggish to escape the gravitational tether. The only gases that consistently manage to slip out the back door are hydrogen and helium, the absolute lightest elements in the entire universe. So, how do they actually escape? There are three main ways these lightweight molecules wind up on a one-way mission to the stars. The first way is simple: heat. The top layer of our atmosphere, called the exosphere, is constantly being baked by the sun. The sun's intense heat causes the molecules to vibrate frantically. Occasionally, a hydrogen atom gets so hot and energetic that it just boils right off the top of the atmosphere into the vacuum of space. The second escape route is a bit more violent. It involves the solar wind, which is a continuous, raging storm of high-energy charged particles blasting out from the sun. Usually, Earth's magnetic field acts as a giant, glowing shield that deflects these dangerous particles. But our atmosphere is full of neutral molecules, atoms that have an equal number of protons and electrons, meaning they have no magnetic charge. Occasionally, a speeding, high-energy particle from the sun crashes violently into a neutral hydrogen atom in our atmosphere. The impact is so intense that the solar particle knocks an electron loose and steals it for itself. In doing so, the solar particle suddenly becomes neutral. Because it no longer has a charge, it is instantly freed from the grip of Earth's magnetic field. If that high-speed collision happens to bump the newly neutral particle on an outward trajectory, it simply flies away into the cosmos forever. Finally, the third way gas escapes has to do with the shape of our magnetic field. The violent solar wind pushes against Earth's magnetic bubble, stretching the magnetic field lines near the poles and pulling them backward into a long tail. Instead of looping safely back to Earth, some of these magnetic field lines are completely snapped open by the pressure. Charged particles from our atmosphere can slide along these open magnetic highways and simply fly off the weak ends, like sparks shooting off a severed live wire. You might be thinking, wow, that sounds terrible. But if our planet didn't have a magnetic field at all, things would be infinitely worse. Just look at Mars. Billions of years ago, Mars had a thick atmosphere, flowing rivers, and deep oceans. But Mars' core cooled down, and its protective magnetic field died out. Without a magnetic shield, the relentless solar wind acted like a cosmic sandblaster, violently buffeting and stripping away the Martian atmosphere molecule by molecule. Today, Mars is a barren, freezing desert. Our magnetic field is the only thing preventing Earth from sharing that exact same fate. But even with our protective bubble, the slow leak continues. Every single second, Earth loses enough hydrogen gas to fill a balloon 1 meter wide. But there's no need to lose sleep over it. Our atmosphere is unfathomably massive. At this incredibly slow leak rate, it will take several billion years before Earth loses all of its hydrogen. By that time, the sun will have expanded into a red giant and swallowed the Earth anyway, so a lack of hydrogen will be the least of our worries. Still, it does make you wonder. Sometime in the distant, unimaginable future, long after the atmosphere has finally drifted away, will an alien species look at a dry, dead Earth through their telescopes and ask the exact same question we ask about Mars today? Was there ever life on that chunk of rock?